Good morning, ladies and gentlemen, boys and girls, friends and neighbors, or good afternoon, good evening, whatever the case may be. And what we'd like to do is have a little video for the quiz that's going to be tomorrow. This is going to be a short 10-point quiz on Wednesday, February 1st. It's going to be complete review over things that you should have been doing over the course of the last couple weeks. So there will be two sets of problems on this quiz. Problem number one, set number one you will need to determine the trigonometric ratios of some angles given on the unit circle, but the key here is you're going to be given a filled out unit circle. So you are going to be given a switch over to a picture of a unit circle filled out that I have actually posted on Google Classroom today. So here is your picture of a filled out unit circle, and you can notice that I have all of the positive angles. I have all the positive angles from 0 to 360. Note that angles can go above 360, but for this particular instance and for this particular case, we're just going to limit ourselves to positive angles from 0 to 360 and negative angles from 0 to negative 360. And so I just ask you to observe those angles carefully, and then with each of those angles is given the particular terminating point for those angles. And this is something that eventually you're going to have to be able to do, is fill out the terminal points for these what we call special angles. Okay, so what we're going to ask you to do is determine the trigonometric ratios of these particular angles. So you might take a picture of that on your phone or something, and just you're not going to tomorrow. You won't have to be able to fill this out, but you're going to have to be able to apply this particular circle. So I'm going back to the Smart Notebook files. And having said that, then, can you use that unit circle to figure out these particular, here will be just 4 example problems. Cosine of 270, cosecant of negative 225, the sine of 135, or the cotangent of negative 120. And certainly this is going to be done without a calculator. So what I'm going to do is I'm going to look at the unit circle that I have, but before I do that, gosh, how do I figure this out? Well, this is something that you're going to need to know. If I go to the next page of my Smart Notebook, this is what you're going to need to be able to know tomorrow. These 6 new definitions of our trigonometric ratios. So given an angle A on the unit circle with terminating point x comma y, the cosine of an angle A is going to be the x coordinate. The sine of an angle A is going to be the y coordinate. The tangent of angle A will be the y coordinate divided by the x coordinate. The secant of an angle, SEC of an angle A, is going to be 1 divided by the x coordinate, and the cosecant of an angle A is going to be 1 over the y coordinate. The cotangent of an angle will be the x coordinate divided by the y coordinate. So if I look at my unit circle, and now let's go back to the problems. If I go back to the unit circle and I'm looking at these particular problems, the cosine of 270, I go to 270 degrees and I look at the x coordinate of that terminating point. And I see that the x coordinate of that terminating point is 0. So the cosine of 270 degrees is 0. Oopsie. The cosine of 270 degrees is 0. If I want to find the cosecant of 225 degrees, I go to the terminating point of negative 225 degrees. I find negative 225 degrees on my unit circle. I have found it. And that's going to be 1 over the y value. Well, if I look at negative 225 degrees on my unit circle, and let's go back here. So that's going to be 1 over the y value. Well, what is the y value? I'm here at negative 225 degrees. The y value is square root of 2 over 2. Therefore, the cosecant of negative 225 is 1 divided by square root of 2 over 2. We don't want to leave this complex rational number, meaning a fraction and a fraction. So we do want to simplify that at least to a single fraction. And if I notice, I can take this guy right here and multiply it by 2 over 2. These 2's cancel, and I get 2 over the square root of 2. You can leave your answer like that, or you can simplify this, i.e. get the radicals out of the bottom. How are you going to do that? Well, we reviewed that. We're going to square root of 2 over square root of 2. Square root of 2 times square root of 2 is 2. 2 times square root of 2, the 2's will cancel, and you would just have the square root of 2. What I would suggest, especially for tomorrow, is just leave your answer 2 over square root of 2, and that's going to be sufficient. I'm trying to give a couple examples of where you have complex rationals as the result of your trigonometric ratios. And then let's go another example, the sine of 135 degrees. What is the sine of 135 degrees? I go back to my unit circle. I find 135 degrees, which is right here. Golly gee, we already figured out because 135 and negative 225 have the same terminating point. So the sine of an angle is the y value of the terminating point. And you notice the y value of 135 is square root of 2 over 2. So that very simply tells me that the sine of 135 degrees is square root of 2 over 2. There's no computation. The only computation needed is to simplify these rationals. What do you need? This is what you need. You need to know the definitions of the trigonometric ratios given in unit circles. This, ladies and gentlemen, is what you will need to memorize. Okay, back to our next example here on this page. I have cotangent of negative 120. What the heck is the cotangent of an angle? The cotangent of an angle, if I go back here, is the x-coordinate divided by the y-coordinate. The x-coordinate divided by the y. So then what do I have to do? I have to find the coordinate point, the terminating point of negative 120 degrees. Go back to our unit circle, and if I look at negative 120 degrees, where is it? Where is it? Well, it's right here. It's right here. You can see, I think you can see my mouse, my cursor right there. That's going to be negative 1/2 over negative square root of 3 over 2. And the cotangent, what's the cotangent? I have those guys here. The cotangent is going to be the x over the y. The x over the y. So the x of that point was negative 1/2. The y of that point was negative square root of 3 over 2. So negative divided by negative makes the whole rascal positive. And if I multiply both top and bottom by 2, these 2's cancel, and I simply have 1 over square root of 3. If you want to leave it as 1 over square root of 3, happy daggone New Year, you can. You can simplify that by multiplying top and bottom by square root of 3. If you want to do that, you can. And then this is going to be square root of 3 over 3, which I have. Or you can just leave it like this. You can't leave it like this. You want to simplify to a single fraction. So you'll have 4 or 5 questions over finding the trigonometric ratios of specific special angles given on a filled out unit circle. That will be set A. Set B will look like this. Set B, we want you to be able to graph an angle on a blank unit circle, a non-special angle. And what I mean by a non-special angle is an angle whose measure is not a multiple of 30, a multiple of 45, or a multiple of 60. For example, here's a blank unit circle, and we're not worried about coordinate points. There were some problems that we were looking at and that we will look at later this week where the terminating points of certain angles were given as arbitrary constants. All we want you to do is to be able to know where different angles are on the unit circle. So I have 4 examples of these types of problems. So if I have 187 degrees, where would that be on the unit circle? Approximately, we're not going exact. Where would negative 218 be on the unit circle? Where would negative 87 be on the unit circle? Where would 290 degrees be on the unit circle? So if you just take a moment and think about where these would be, I will go over the correct sketch of these particular angles. 187, let's see, well, 187 is going to be over 180. Oh, but I think this is going to be in quadrant 3. So figure out what quadrant they're going to be in first, and then decide how far into that quadrant. And note, don't forget that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Well, I think 187 is going to be in quadrant 3. I think, ooh, negative 218. Negative 218. Ooh, I think that that's going to be in, I got negative 90, negative 180, negative 270. This is going to be in quadrant 2. Where's 290 going to be? 290 is greater than 270, less than 360, so this is going to be in quadrant 4. It makes sense. Where's, negative 87, negative 87 would also be in quadrant 4. So we just need to know how far, or approximately, for it to be accurate, approximately where would these angles lie. And so let's look at them. I have them sketched on the next slide. So here's 187 degrees. So 100 in positive, so you're going to go this way. And that's not a bad representation. It probably would be a little bit less. But that's going to get you the points, because you know you're not that far into quadrant 3, and you're greater than 180. So that would be a good sketch of 187 degrees. What about 218? Negative 218. Well, negative 218, you're going counterclockwise. And so you're going to go, this is negative 180. This would be about negative 218. So that's about negative 218. What about negative 87 degrees? Note the direction of the arrows. Negative 87 degrees will be negative 87 degrees. What about 350? Positive 350. Positive 350 is going to be a counterclockwise angle, and I'm going to start here. I'm going to use the appropriate color, and I'm going to go all the way around here and stop that rascal right there. Okay, so that's the essence of the short 10-point quiz that will be tomorrow. This is a short 15-minute video to help you prepare for the quiz tomorrow. And I will say that, golly gee, I'm just going to stop with golly gee. All right, so I will see you tomorrow, I'm sure.